Gradient is also common in Y. Find the gradient of this, find the gradient of that, especially in the topic of coordinate geometry. How can we find gradient? You are talking of a gradient of line AB. Gradient of line AB. Gradient is the same thing as slope. You will be asked to find slope. Don't be carried away. When you say slope, it's the same thing as gradient. These are the language of mathematics you can say at times. When you say slope, slope is the same thing as gradient. So when you have to find the gradient, or when you have to find the slope, they are saying the same thing. Now, we notice that tan theta equals to y1 minus y2 all over x1 minus x2. Tan theta equals to y1 minus y2 all over x1 minus x2. That is how to find the gradient of any particular question given to us. Now take for instance, if you are to find the gradient, I want to look for a question here. If you have to find the gradient of anyway, this is the formula for finding the gradient, but other way around, there are some occasions where you can still use another formula for finding the gradient. Once a gradient is equal to another gradient, if you are given two different lines, one gradient is equal to the other one, then the gradients are parallel to each other. For instance here, if you are given example, find the total gradient now. Yes, gradient. Find the gradient of example. Find the gradient of line joining the following pairs of points. A is and B is. Now, how do we find the gradient here? How do we find this gradient? Then we talk of gradient AB. Gradient AB, because you have point A and point B. The gradient there will be, according to our explanation here, the gradient will be 7, that is y2 minus y1 all over x2 minus x1. So what is y2? Y2 is 7 minus 3, and this is 3 minus 1. So we have 4 over 2, which is equals to 2. The gradient is equals to 2. But don't forget, when the gradient of that one is 2, we can still use tan theta to find our real gradient. You can still use tan theta to find out. That is, if you are given an angle on one side, you can use it to find the gradient of any given line. We are going to talk about, especially this is a coordinate geometry. It's not the gradient we are talking about here at times is not all that the same with the gradient that you can find in the graph. Now, if you are talking of gradient of a parallel lines, gradient these are cheap questions that you can easily pass in a while. Gradient, if you understand what to do. Gradients of parallel line. Parallel line. Gradients of parallel lines. Gradient of parallel lines. Take for instance, if you are given, you have to take note of something here. When we talk of parallel lines, it means we are talking of two different parallel lines. Because you say parallel lines. If you talk of, for example, you have this is a line AB, then line PQ. They are two. These are the two parallel lines. We have the first one AB, the second one PQ. What are we saying here? We are saying that the gradients here can be equal if the two lines are parallel. If the two lines are parallel, then their gradients will be equal to each other. Now, note here that since line AB is parallel to line PQ, since line AB is parallel to line PQ, then their gradients will be equal. They will have equal gradients. They will have equal gradients if the what? If the two lines are parallel. If the two lines are parallel, they will have the same gradient. So how do we solve this? How do we solve this? Now we talk of example. Example, given 2 points. Given 2 points. A 1, 3 and B 5, 5 and C -1, 4 and D 1, 5. These are two parallel lines. These are two parallel lines. The question now says that show that AB, that is, show that line AB is parallel to line CD. Line AB is parallel to line CD. Show that line AB is parallel to line CD. Show that line AB is parallel to line CD. Now, these are the type of questions that you can come across in any examination that you want to write, either WASSCE or NECO. You have been given 2 points, A and B. A and B is a line, and C and D is also a line. Now, we have to show that line AB is parallel to line CD. If line AB will be parallel to CD, there is a condition under the coordinate geometry. The condition there is that the gradient of line AB must be equal to the gradient of line CD. If the two lines gradients are equal, then we can now confirm, we can now agree, we can now conclude that line AB is parallel to CD. We can now conclude that line AB is parallel to CD. Now, how do we solve this? We talk of 2 points. The first one, consider point A, which is a 1, 3, and B, 5, 5. We want to consider those 2 points. Now, here, our point is AB. So, what is the gradient of AB? We want to find the gradient of AB. The gradient of AB will be what? Y1, is Y2 minus Y1 all over X2 minus X1. So what is Y2? Y2 is a 5 minus 3 over 5 minus 1. And this is a 2 over 4, which is 1 over 2. The gradient of AB is a 1 over 2. That is one line. We need to consider the second line, which is we need to consider point C of minus 1 and 4, and point D of 1 and 5. If we are to find the gradient here, the gradient of CD, the gradient of CD will be 5 minus 5 minus 4 over 1 minus 1 because of this negative 1. So it will be 1 minus 1. So this gives us 5 minus 4 is 1 all over 1 plus 1. So this gives us 1 all over 2. This gives us 1 all over 2. Now, we have find the gradient of AB, which is half, and gradient of CD, which is half. Then, what is the next thing? Since the gradient of AB equals to the gradient of CD, then the lines are parallel. We will now conclude that since gradient of AB is equal to gradient of CD, which is all of them equals to half, then it means line AB equals to line CD. Line AB equals to line CD. That is the reason that will state that if line, a particular line gradient is equal to the other line gradient, then it means that the two lines are parallel. It means the two lines are parallel. Now, before we move ahead, there's another way of asking the question from this point. Supposing you are given this problem to solve, example 2, let A be a coordinate of 1 and 3, and B be a coordinate of minus 1 and 5. Then we talk of C, a coordinate of 2 and Y, and D, a coordinate of 4 and 7. The 4 points. There are 4 points. Okay? There are 4 points. If AB is parallel to CD, Then find the value of y. Find the value of y. Let a equals to equals to 1 and 3, and b equals to -1 and 5, and c is 2 and y, and d is 4 and 7. B 4 points. If AB is equal to CD, find the value of y. Find the value of y. Find the value of y. Now we talk of line AB. AB is prior to this. We need to find the gradient. We need to find the gradient of AB first. We need to find the gradient of AB because we have been told in the question that line AB is parallel to CD. We have been told that line AB is parallel to CD, and we have to find the value of y here. So in this case, we have 5 minus 3 minus 1 minus 1. This is equals to 2 all over minus 2 minus 1. That's where we divide half minus 1. So it means our gradient, the gradient of AB is minus 1. Where we say 5 minus 3 and minus 1 minus 1 minus 1. So we have 5 minus 3 will give us 2, and minus 1 will give us minus 2. When we divide through, we have minus 1. So it means the gradient of AB is minus 1. Now we need to find the gradient of CD. Gradient of CD. Gradient of CD. Gradient of CD is a 7 minus y, 4 minus 2. 7 minus y all over 4 minus 2. Okay? And this will be equals to 7 minus y all over 2. 7 minus y all over 2 is our gradient there. In this case, if our gradient of AB is minus 1, definitely the gradient of CD is supposed to be minus 1 as well, because it has been stated that AB is parallel to CD. So we now say that once they are parallel, it means their gradient must be equal. Now that we have gradient of 7 minus y over 2 in gradient CD, it must be equal to minus 1 of the gradient of AB, because they are parallel. Then you cross multiply, because we are looking for y. That's, we are trying to find our y here, to find y. Then we say 7 minus y all over 2 equals to this. Meaning that 7 minus y equals to minus 2. 7 equals to minus 2 plus y. Then this is a 7 plus 2 equals to y. And then y equals to 9. Y equals to 9. This is now the value of y that we have to find from this question. So if you are fortunate to see this one in the exam, it is now easy for you to determine the unknown given to you once the two lines are parallel. Once the two lines are parallel. Then we forge ahead. We go to the other aspects of the question first. Let's talk about gradient of perpendicular lines.